This will be the first in a series of electrical practice problems. In this video, we'll be looking at a problem related to a series parallel circuit of a DC network. Once I am finished with this series of problems, I'll be posting them in my Stan store, and you may find them at this web address. This is practice problem number 1. In this problem, we are to determine the voltages V1 and V2 in this network. To start with, we can redraw the original network like this. This series combination gives us 6 k ohm and 3 k ohms in parallel with 6 k ohm, and it is given by 3 k ohms times 6 k ohms all over the quantity 3 k ohms plus 6 k ohms, which gives us 18 k ohms over 9 k ohms, or 2 k ohms. We can redraw the circuit now to look like this: 2 k ohm resistors in series. Before continuing, I'm going to use something called the voltage divider rule. So let's take a quick look at that. The voltage divider rule is demonstrated by the solution to this circuit: the voltage source feeding 2 series resistors. In this circuit, the source voltage will be split into 2 resistors, and Kirchhoff's voltage law tells us that the voltage drop across 2 resistors must sum to equal the source voltage. Therefore, the voltage drop across each of these series resistors will be equal to that resistor's value divided by the sum of the resistors in series times the source voltage. That is, V1 is equal to R1 divided by the sum R1 plus R2 times the source voltage. And V2 is equal to R2 divided by the sum of R2 plus R1 times the source voltage. Now, the voltage divider rule can be sequentially applied. V1 is equal to 2 k ohms divided by the quantity 2 k ohms plus 2 k ohms times the 12 volts, which equals 6 volts. Looking at the original network, we can again use voltage division. The voltage drop across the 2 k ohm resistor is 2 volts. This gives us the solution to the original problem, as in most cases there is more than one way to find a solution. Another way would be to use Ohm's law to find the current flowing through the areas of V1 and V2. As in most cases, there is more than one way to find a solution. Another way would be to use Ohm's law to find the current flowing in the areas of V1 and V2. In order to do that, we take a step back and use Ohm's law to calculate the current flowing from the 12-volt power supply. We know the voltage and the series resistance, so the current flowing from the 12-volt power supply is 3 milliamps. We then return to Ohm's law to find the voltage V1. We know that the current flowing through the 2 ohm resistor, so the voltage drop across V1 would be 3 milliamps times 2 k ohm, which will give us 6 volts. Since we also know the voltage drop across the 4 and the 2 k ohm series resistors, we can use Ohm's law to calculate the current through these resistors, which is 6 divided by the quantity 4 plus 2, which is equal to 1 milliamp. We can again use Ohm's law to calculate the voltage drop across the 2 k ohm resistor, which is V2, and is calculated by multiplying 1 amp times 2 k ohms to give us 2 volts. which not surprisingly gives us the same solution that we calculated previously using voltage division. This video is part of my electrical technical information series. In this series, I'll be covering essential topics to help you understand electrical systems. These topics are small excerpts from my courses located in my stand store, which you can access by going to this web address. By going to this web address, you'll be asked for your name and email address. By submitting your email address, it will not be shared with anyone else or any other company, and it will allow me to periodically let you know when updates occur in these lessons. Here is just a sample of some of the reviews that I've received for my courses. As I said, this is just a sampling, and I will apologize in advance for the brief look at them, but you get the idea that the courses have been highly rated, most of them 4.5 to 5.0 out of 5 points.